Here is another really very interesting question again. We have a wooden block on which a coin is kept, and this was floating on the water initially, this wooden block, with a height L of the wooden block below water, and this height of the liquid initially was H. After some time, what happens is that the coin falls in the water. You now need to find out what happens to L and H. That is, in the sense, do they increase or do they decrease? What happens to L and H? So for going about this question, you need a very conceptual idea of the whole thing. Now let us first consider L. L is the submerged height of the block A in water. Now initially, this block was displacing an amount of water whose weight was equal to the weight of A plus weight of coin. Listen to me carefully again. Initially, this block A was displacing a volume of water whose weight was equal to the weight of A plus weight of coin. Now when the coin falls in the water, it just has to balance its own weight by the buoyant force. So this block A will displace only a volume of water whose weight is equal to the weight of A. So finally, after the coin has fallen in the water, this block A will displace a lesser volume of water. So when this will displace a lesser volume of water, lesser height of the block A will be inside water. Therefore, L decreases. So after some time when the coin falls in the water, L decreases. We've got the answer for that. Now let us study what happens to H. Now for studying the variation in H, the volume of the water in the container was fixed. Listen to me very carefully. The volume of the water in the container was fixed. Now this height H depends on the volume of water which is displaced. That is, initially this block A was displacing some water, due to which it maintained a height H. If we push this whole system more down, it will displace some more volume of water and this height H will increase. But now what has happened is that this coin has fallen into water. So it is all a question of how much water we are displacing. If we displace more water by pushing this down, this height H increases. If we pull this system upwards, this height H decreases. Now let us see whether we have increased the displaced water or decreased the displaced water. Now initially when the coin was on top of this, we were displacing a volume of water whose weight was equal to the weight of these two objects. Therefore, let us consider the coin only. The coin was displacing a volume of water through this with the help of A, whose weight was equal to the weight of this coin. Now when the coin falls in the water, it displaces a volume of water whose volume is equal to its own volume. When the coin finally falls in the water, it is displacing a volume of water equal to its own volume. Now initially it was displacing a volume of water whose weight was equal to its own weight. Now since the density of water is less than the density of coin, therefore initially it was displacing a larger volume of water. Therefore what happens is that the value of H also decreases. So the tricky part in this part, the second part, was that when the coin left the block A, the volume A went a little bit upwards, due to which the block A now displaced a lesser volume of water, but the coin went down and it displaced some volume of water. So we have to check whether the decrease in the displacement was greater than the increase in displacement or not. So for checking this, we used the concept of the density of the coin. When the coin was on top of this, the volume of the water displaced due to the coin was equal to the volume of water whose weight is equal to its own weight. Now here, when the coin has fallen in the water, it is displacing a volume of water equal to its own volume. Now a volume of water whose weight is equal to this weight will be obviously greater than this volume. Therefore initially it was displacing a greater volume of water. The final displacement of water is less. Therefore the value of H decreases. So the answer final is L also decreases and H also decreases.